Hello, this is section 6.1 in the textbook. We're talking about normal distribution. And when we talk about normal distribution, we're referring to the bell-shaped curve that you see here on the screen. So these bell-shaped curves are normal distributed of the variables. And so what you need in order to construct these curves are the mean or the average and the standard deviation. And so using this knowledge, we're going to be able to answer these questions here on the left, and we'll start with 6.18. And it talks about two distributions. We know that they're normally distributed, so we know that they're follow this nice bell-shaped curve. And it has the first one has a mean of 1 and a standard deviation of 2. The other one has a mean of 2 and a standard deviation of 1, and so it's asking which one has the wider spread. And so we can use figure 6.8 to answer this question. And so as you can see, one of the curves has a larger mean. And so we could be tempted to say that, okay, because the mean is 2 here, that would mean a larger spread. But as we can tell here, from this figure 6.8, that the spread of the curve is not determined by the average or the mean, but it is determined by sigma, the standard deviation. Okay, so the standard deviation is what determines how wide or how narrow the spread is. So the answer to 6.18, it would be the first one with the standard deviation of 2, because the standard deviation determines the spread of the curve. And that's how you would answer that question. All right, 6.37 is a little bit longer. I won't read the introduction here, but it's talking about the length of a tarantula, and it says that you have a mean of 18.14 millimeters, and the standard deviation is 1.76 millimeters. And then we have a series of questions here, A, B, C, D, and E to answer. And so all these questions here illustrate many of the points that were written in the text. So let's just go over them now. So it asks us in part A to sketch the distribution. And let me see if I can get a text box here. And so I won't be able to draw it, but I'll tell you how you can construct it. Actually, before I do that, I want to show you what we're trying to accomplish. For part A, we're basically figure 6.9. We're trying to create this curve right here. Okay, just like we have these three curves here, you're creating just one curve, right? Because you have a mean and you have a standard deviation. And so because you have those two, you are more than capable to create this curve. And so the mean is going to be in the middle right here. So your 18.14 that's given to you, you'll put that in the middle right here. And then you notice here that these tick marks, right? You have mu, which is the mean, plus the sigma, which is standard deviation. And then this is actually the formula. And so you're just going to plug in mu. You plug in mu. So I'll do one of them. I'm not going to do all of these just because there are a lot. But let's say I'm going to do the ends. So I'm going to do mu minus 3 sigma, and then mu plus 3 sigma. So I'll do those two for us together. And then you can always verify my calculation. So mu is 18.14 millimeters. And then minus 3 sigma, and sigma is 1.76 millimeters. That gives us a 12.86, and this is not part B, it's still part A. And then the other end, the mu plus 3 sigma is going to be 18.14 plus this time 3 sigma, which is 1.76. That gives us 23.42 millimeters. So, all right. So this is this point here, this point here. So now you got the ends and you got the mean. And all you have to do is just create this little curve here, and then that's how you do it. You can also do these other tick marks too, just that I won't be able to fit them all in this one video. The next part is B. Obtain the standard version of z of x, and I have this text box right here that's taken from the textbook that tells us that the standard version of a normally distributed variable x is z equals x minus mu over the standard deviation. And so in order to answer B, we're going to say z equals x, whatever that x is going to be, minus mu, which is 18.14 millimeters. We'll put these in parentheses, divided by the standard deviation, which is 1.76 millimeters, and that's part B. Part C is asking us to sketch the graph. I won't be able to do that here. It won't come out nice. So, but basically, you're constructing this curve, but when it's the standardized normal distribution curve, your midpoint is 0 and your ends is 3 and -3. And so that's what you would create. You would create a curve where 0 is at the center, -3 is at your left side, the far left, and then +3 is on your far right. Okay, so I'm just going to say create graph with mu. I don't know how to create mu. It's not a u really, but we're going to use that just as a placeholder. It's going to be 0, so that your center is 0. Alright, moving forward, part D, you're given 2 measurements, and so now you want to know the percentage in between. To do that, you will use the equation that we got in part B. So you'll do 16 minus 18.14 parentheses divided by the standard deviation, which is 1.76. That should give you an answer of -1.22. And then 17, we plug in 17 this time. 17 minus 18.14. Oops, 14. I forgot the parentheses. Yeah, 1.76, which is the standard deviation. That should give you a answer of -0.65. And once again, you can check my math. And so basically, this graph that you're going to construct in part C, where the mid is 0 and the far ends are -3 and 3 respectively, basically it's mapping it there. And so it's part of the standardization of the graph. And that's really useful when you have graphs that have like parts like figure 6.8, where you have different means and different standard deviation. By combining all this into one graph, it actually helps you to do analysis, which is much better. And then the last part E, it asks about the length exceeding 9 millimeters that is equal to the area under the standard normal curve. So the standard normal curve, we use the z equation, and so we'll get we'll put 19 minus 18.14, and I always forget the parentheses. We want to do the parentheses. Do the subtraction first, then divide by 1.76, and that will give you 0.49. And so 19, if we created the graph, you'll see that 18 is in the middle, and then the 19 would be right here. And so it's saying anything exceeding greater than, so it'll be moving towards to the right. So the answer for part E is under the standard normal curve that lies under the standard normal curve that lies to the right of 0.49. Okay. And so in this video, we went over briefly what the normal distribution is supposed to look like, which is a bell-shaped curve that has a mean and a standard deviation. We also learned about the standardized normal distributed variable, which converts these different means and standard deviation into one single nice curve. And we were able to find some percentages based on this equation, the z equation. Okay. Thank you.